Ever wondered what the stickiest substances on Earth could be? Today, we're diving into a world of stickiness that will blow your mind. We're not just talking about the gum under your shoe or the glue that holds your world together. Oh no, we're venturing into the realm of the bizarre, the fascinating, and the downright mind-boggling. From the natural world to the man-made, these substances have some incredible properties and uses. We've ranked them based on their adhesive strength, the science behind their stickiness, and how they interact with different materials. Some of these substances are so sticky, they could hold together a convoy of semi-trucks. Others have uses that are as surprising as they are ingenious. So, are you ready to delve into this sticky countdown? Buckle up, because we're about to uncover the fascinating world of the top 5 stickiest substances on Earth. Stay tuned as we start our countdown with the 5th stickiest substance on Earth. Kickstarting our countdown at number 5 are the sticky feet of geckos. Now, we're not talking about your average sticky note here. We're diving into the world of van der Waals forces, a type of physical bond that's a game changer in the world of adhesion. You see, the secret to a gecko's gravity-defying abilities lies in the millions of tiny hair-like structures on the soles of their feet, known as setae. Each of these setae ends in hundreds of even smaller structures called spatula. When these come into contact with a surface, they create a strong adhesive force using van der Waals forces. These are weak, short-range electromagnetic forces that occur when molecules come close together. They're so tiny, you'd need a microscope to see them, but their collective strength is phenomenal. But what's really cool about this is that geckos can turn this stickiness on and off at will, simply by changing the angle of their feet. This allows them to stick to almost any surface, yet move around with ease, something that's proving to be a real inspiration for scientists and engineers. Imagine, for instance, if we could harness this technology and scale it up. How many semi-trucks do you think we could stick together using gecko-inspired adhesive? Well, theoretical calculations suggest that a mere square inch of this stuff could hold a weight equivalent to 18 semi-trucks. That's right, 18. This nature-inspired technology is under research for potential future applications, including creating gecko tape for astronauts to use in zero-gravity environments, developing new surgical adhesives, and even creating Spider-Man-like climbing gear. So the next time you see a gecko climbing up a wall, remember, you're witnessing one of the stickiest phenomena in nature. Sliding into the 4th spot on our countdown is none other than spider silk. Spider silk, a substance we've all encountered, whether it's stumbling through a web on a morning walk or marveling at a spider's intricate design glistening in the sunlight. But what makes this material so fascinating is its sticky nature, produced naturally by our 8-legged friends. Spiders spin their silk from proteinaceous spider silk glands within their bodies. It's a complicated process that involves the liquid protein hardening as it's drawn out, resulting in strands thinner than a human hair. The spider uses this silk to create its web, a masterpiece of engineering, and the stickiness of the silk plays a vital role in trapping unsuspecting prey. But it's not just the stickiness of spider silk that's impressive. This substance is also incredibly strong and durable. In fact, weight for weight, spider silk is stronger than steel. Now, let's put that into perspective. Imagine, if you will, a strand of spider silk, thickened to the width of a pencil. This strand could potentially hold the weight of a full-grown man. Scale that up, and theoretically, a spider silk rope around 2 inches in diameter could hold the weight of a semi-truck. That's right, a single semi-truck suspended by a rope made from the silk of a spider. But it doesn't stop there. If we were to weave a net of this super silk, it could hold not 1, not 2, but up to 5 semi-trucks without breaking. That's the power of spider silk. Despite its strength, spider silk maintains its flexibility, which is another factor that contributes to its stickiness. This flexibility allows it to stretch and absorb the impact of fast-flying insects, wrapping them in a sticky embrace. Spider silk, a substance of strength and stickiness, truly a marvel of the natural world. Bouncing into our 3rd spot is natural rubber. This stretchy, flexible, and yes, sticky material has a history that's just as fascinating as its properties. Originating from the sap of the Hevea brasiliensis tree, or more commonly known as the rubber tree, natural rubber was first discovered by indigenous tribes of Central and South America. They found that when this sap, also called latex, was dried and heated, it transformed into a sticky, elastic substance that could be manipulated into various shapes and forms. Now let's talk about the stickiness of natural rubber. When heated, the polymers in natural rubber become flexible and sticky, allowing it to bond with various surfaces. But how sticky is it exactly? Well, imagine a semi-truck, those monstrous vehicles that dominate the highways. Now picture 10 of these trucks lined up. With the right amount of heated natural rubber, you could stick these 10 trucks together, creating a formidable convoy of rubber-bound metal. That's some serious stickiness. But the story of natural rubber doesn't end with its impressive adhesive properties. This substance has a multitude of uses that span across various industries. From the soles of our shoes to the tires on our vehicles, from the erasers on our pencils to the gloves used by surgeons, natural rubber has become an indispensable material in our everyday lives. Its unique combination of stickiness, elasticity, and durability makes it a versatile and practical substance. In the world of engineering, for instance, natural rubber is used to create vibration isolators and shock absorbers, capitalizing on its elastic properties. In the medical field, it's used to make gloves, catheters, and other medical equipment due to its flexibility and resistance to wear and tear. In essence, natural rubber is more than just a sticky substance. It's a testament to the wonders of nature, a material that has shaped our world in more ways than we can count. So next time you erase a mistake with your rubber eraser or drive your car with rubber tires, remember the humble origins of this sticky, stretchy, and incredibly useful substance. Natural rubber, a sticky substance that's become an integral part of our daily lives. Sweetly sticking to the second spot on our list is honey. This golden goo is not only a natural sweetener, but it's also one of the stickiest substances on Earth. Produced by bees from the nectar of flowers, honey's stickiness is due to its low moisture content and complex composition of sugars. Now let's talk about semi-trucks. Imagine, if you will, a line of 20 semi-trucks, bumper to bumper. If we slathered honey all over the connecting ends, how many do you think could stick together? You'd be surprised. The answer is a whopping 10 trucks. That's right, the sticky power of honey could, in theory, hold 10 semi-trucks together. From sweetening our tea to holding semi-trucks, honey is a versatile substance. It's used in cooking, baking, medicine, and even skincare. Honey, a sweet and sticky delight that's been captivating humans for centuries. Topping our list as the stickiest substance on Earth is pitch. This black, viscous material, often used in waterproofing and paving, is not only known for its adhesiveness, but also for its incredibly slow-dripping nature. Let's get to the heart of pitch's sticky nature, its viscosity. Viscosity is a measure of a fluid's resistance to flow. In simple terms, it's how thick or sticky a liquid is. And pitch, it has a viscosity about 100 billion times that of water. This means it flows, albeit extremely slowly, making it one of the most viscous substances known to man. This slow flow of pitch was famously demonstrated in an experiment that started back in the year 1927. Known as the pitch drop experiment, it was intended to prove that, despite appearing solid, pitch is actually a very, very slow-moving liquid. A sample of pitch was placed in a funnel and left to drip. And drip it did, but oh so slowly, with only 9 drops falling in nearly a century. Now, to give you an idea of just how sticky pitch is, let's bring back our semi-truck example. If you were to coat a semi-truck with a layer of pitch, not only would it stick, but it would also take an unimaginable amount of force to unstick it. In fact, you could probably stick 2, 3, maybe even 4 semi-trucks together with enough pitch. Just remember not to park your semi-truck near a pitch factory unless you're planning to stick around for a while. So there you have it. Pitch, a substance so sticky and slow, it redefines our understanding of solid and liquid states. That concludes our sticky countdown. We've journeyed through the world of adhesion, from the fascinating microstructure of gecko feet that can scale smooth surfaces to the resilient spider silk, stronger than steel, yet flexible. We've explored the versatility of natural rubber, a substance that revolutionized industries, and the sweet, viscous charm of honey that's not just a treat, but a natural adhesive too. Finally, we delved into the extraordinary world of pitch, a substance so sticky it can hold semi-trucks together. What a world we live in, full of incredible wonders, right down to the stickiest substances around us. Do you have a favorite? Or perhaps there's another sticky contender we missed? We'd love to hear your thoughts. Don't forget to subscribe, follow, like, comment, and share this video. Stay sticky, folks.